Somewhere east of Salt Lake City, in the summer of 2016, a man got on a bicycle and rode out onto ground that used to be underwater. Not underwater 1,000 years ago, underwater within living memory, within his own memory. His name is Kevin Perry. He studies the air for a living at the University of Utah. And on this particular ride, he wasn't wearing spandex and he wasn't chasing a personal best. He was wearing gloves. He had sample bags folded into his jersey pockets and a plan that would end up taking him more than 2 years to finish. He rode out across cracked, pale ground that stretched to the horizon in every direction, and every 500 meters, he stopped. He knelt down. He scooped a sample of the crust into a bag, sealed it, labeled it, and got back on the bike. Then he rode another 500 meters, and did it again, and again, for 2,300 miles, over more than 125 days spread across 2 years. Stopping by the end at roughly 1 point for every 92 acres of ground, taking 3 samples at each site, 2 from the surface and 1 from just beneath the crust, until he had almost 16,000 samples, over 4 tons of dirt carried home in bags on a bicycle. Try to picture that for a second. Not a lab, not a drone, not a satellite doing the work from orbit. A man on a bike, treating a dying lake like a crime scene that needed to be measured inch by inch because nobody else had done it and somebody had to. What was he riding across? Not desert, not badlands that had always been this way. He was riding across the floor of the Great Salt Lake, the exposed bed of a lake that, within his own adult lifetime, had covered this ground in water. And he wasn't out there for the view. He was out there because he suspected that what the water used to hide, the air was about to start delivering to 2.5 million people downwind, most of the state of Utah, one dry, windy afternoon at a time. Here's the thing about a shrinking lake that nobody tells you. The water leaving isn't the disaster. The water leaving is what reveals the disaster. For more than 100 years, that lake had no way to get rid of anything that flowed into it. Rivers carried in runoff from mining, from industry, from just the ordinary erosion of a mountain range, and none of it ever left. Not 1 gram. It just settled, year after year, decade after decade, into the mud at the bottom. The lake wasn't cleaning any of that away. It was hiding it, sitting on top of it, holding it down, safely out of the air, out of anyone's lungs, for exactly as long as it stayed full. It is not full anymore. And what Kevin Perry found, riding across that newly bare ground sample by sample, is going to take a while to tell you properly, because it is stranger and slower and more disturbing than a headline can hold. There's a reason people who study this call it a 100-year secret coming due. I want to walk you through it the way he found it, kneeling in the dirt 1 bag at a time, because the ending genuinely changes the way you'll think about breathing in that city tonight, right now, whether you've ever been to Utah or not. Let's start with the book that actually sent me down this rabbit hole, and the man whose name is stitched through almost every serious piece of research on this lake for the last decade. There's no single spine book here, because this isn't a story that's finished enough to be a book yet. This is a story still being written in real time by a small group of scientists who keep publishing updated numbers as the lake keeps dropping. So instead of one author, I want you to hold on to 2 things: Kevin Perry's bike survey, which is the foundational map of what's actually sitting in that lake bed, and a document from January of 2023 called Emergency Measures Needed to Rescue Great Salt Lake from Ongoing Collapse. 32 scientists, led out of Brigham Young University by a researcher named Benjamin Abbott, putting their names on a public warning that the lake, as they understood it then, was on a path toward essentially disappearing within about 5 years if nothing changed. I want to be upfront with you about something, because this channel doesn't get to earn your trust by hiding the messy parts. Some of what I'm about to tell you is settled, measured, verified 6 ways, and some of it is genuinely disputed, even among the people who study this lake for a living. I'll tell you which is which as we go. That's the deal. So let's go back to what Perry actually found out there, kneeling in the dirt. He wasn't just collecting samples to fill a shelf. Every batch got consolidated, nearly 16,000 individual scoops folded down into 122 batches, and then screened one by one for 53 different elements. 53. Think about that number for a second. That's not a scientist checking for one suspected contaminant. That's a scientist who genuinely didn't know what he'd find, casting as wide a net as the instruments would allow, because 100 years of runoff doesn't arrive with a label on it. And here's what came back. 9 heavy metals turning up at levels that made his team sit up. Arsenic, cobalt, antimony, lithium, manganese, vanadium, zirconium, copper, lanthanum. 9 names sitting in ordinary-looking pale dust in ground that 2.5 million people live within breathing distance of. Now, hold that number, 9, because I'm going to come back to it. Most of those 9, when measured against the government's own screening levels for what's safe to have sitting around where people live, don't cross the line by very much, if at all. But one of them does. One of the 9 clears the residential safety threshold by a margin that isn't subtle. I'm not going to tell you which one yet. Not because I'm being coy for the sake of it, but because I want you to sit with the shape of the problem first. 9 different toxic legacies, all deposited by different sources over different decades, all waiting in the same crust, before I tell you which one is the one actually keeping researchers up at night. Because here's what makes this different from a normal contamination story, the kind where you can point to one factory, one spill, one bad year. This lake has no outlet. Not underground, not a river flowing out the other side, nothing. Water only ever leaves it one way, evaporation, straight up into the sky, leaving everything it was carrying behind. Every river that has ever fed into the Great Salt Lake, carrying snowmelt off the mountains, carrying runoff from over a century of mining in the ranges around it, carrying whatever ordinary industrial life along the Wasatch Front produced, every one of those rivers made a deposit into this basin, and not one of those deposits has ever been withdrawn. Picture a bathtub with the drain sealed shut and 100 years of faucets running into it, each one carrying a little grit, a little residue, a little of whatever was upstream. The water rises and falls with the seasons, but the sediment just accumulates on the bottom, undisturbed, compounding. That's not a metaphor for how the lake behaves. That's literally the physics of what a terminal lake is, a basin with income and no expense for over a century. And for most of that century, it didn't matter because the water was always there, sitting on top, holding all of it down. It isn't anymore, not the way it used to be. In November of 2022, a monitoring station that has tracked this lake for generations recorded the south arm at 4,188.5 feet above sea level, the lowest level ever measured. Not the lowest in a decade, the lowest ever recorded, full stop, on an instrument record that goes back generations. Earlier that same year, in July, it had already hit a low of 4,190.1 feet, and then, 4 months later, it dropped even further. The lake didn't so much reach a new low as blow past one low on its way to setting another. At its historic average, this lake covered something like 1,700 square miles. By the time it bottomed out, the surface had fallen towards something closer to 800 to 950 square miles. Roughly half its historic footprint gone, not into some other body of water, but straight up into the atmosphere, leaving the bed it used to cover sitting exposed under the sun. And that exposed bed is not empty ground. It is, quite literally, the inside of that sealed bathtub, laid bare for the first time in most of our lifetimes. Perry's bike odometer was measuring the size of that reveal, one 92-acre grid square at a time. And what he found underneath his tires and under his fingernails was 100 years of everything the water had been asked to hold. But not all of that bed is equally dangerous, and this is where the story gets more precise and stranger than a simple picture of a toxic wasteland. Nature, it turns out, built its own lid. When lakebed sediment dries out, minerals and salts in it bind together and form a crust, a thin, hardened skin across the surface. And by Perry's own team's estimate, something like 3/4 of the exposed bed, roughly 76% of it, is currently locked down under this crust, stable, not going anywhere on a windy day. Think of it like the skin that forms on top of a can of paint left open too long. Underneath, it's still wet, still loose, still capable of moving. But that skin on top holds it in place, right up until something breaks it. A footstep, a tire, a grazing animal. A hard enough gust of wind, cracking dry ground the way a drought cracks a riverbed, Except this crust isn't just dirt. This crust is the lid on the bathtub. So of all that exposed ground, only a fraction is actually active right now, actually shedding dust into the air on a bad day. Perry's team put a number on it. About 9% of the exposed lakebed, something like 175 square kilometers on the order of 43,000 acres, is what they call an active dust source today. Not the whole 800-plus square miles of newly bare ground, a specific, mapped 9% of it. That should sound like good news, and in a narrow sense it is. But sit with what that number actually means. 9% isn't a fixed number. It's a snapshot of how much of the lid has broken so far, and every additional foot the lake drops exposes more crust to sun, wind, and cracking. The 9% is not the disaster. The 9% is the leading edge of it. Perry's team didn't just measure how much crust had failed. They mapped exactly where. The active dust sources aren't spread evenly across the basin. They cluster in specific places with names now familiar to anyone who follows this closely. Farmington Bay, closest to the population centers along the Wasatch Front, Bear River Bay, Gilbert Bay, Gunnison Bay, out on the lake's remote northern arm. Each one a hot spot, a place where the crust has already given way and the sediment underneath is exposed to wind. And when the wind picks up over one of those hot spots, this isn't a hypothetical. It's already a recurring event. Right now, researchers count something like 15 large dust storm events blowing off this lakebed in a typical year. Quantifiable, trackable plumes of lakebed dust rising into the air and drifting toward the very corridor where 3/4 of Utah's population lives. 15 times a year, on average, right now, at the current partial stage of crust failure. Not a future projection, a present tense count. And the expectation, as more of that 76% of stable crust cracks open over the coming years, is that this number rises. Not because anyone thinks the wind will blow harder, because there will simply be more broken lid to pick up and carry. Here's where I want you to slow down with me for a second, because this is the point in the story where an abstract mineral survey turns into something that happens to a body. A dust storm off a normal patch of desert is unpleasant. Grit in your eyes, dust on your car, a bad afternoon. A dust storm off this specific ground is carrying, in smaller or larger concentrations, depending on exactly which hotspot it tore loose from, a blend of 9 documented heavy metals. Arsenic among them. Lifted off crust that has been sealed since before anyone currently breathing was born, and put back into the air over a metropolitan corridor of 2.5 million people, roughly 3 out of every 4 people living in the entire state. Nobody chose to be downwind of this. It isn't a factory with a smokestack you can point at or a chemical plant with an address. It's a lake. The same lake people paddleboard on, the same lake migratory birds stop at by the millions, the same lake that shows up on the state's own license plates. And a portion of its historic footprint has quietly become, on the wrong afternoon, a low-grade airborne delivery system for the exact material Kevin Perry spent 2 years bagging by hand, one bicycle stop at a time. Now let's go back to that number I asked you to hold on to. 9 metals found in troubling concentrations across that lakebed: cobalt, antimony, lithium, manganese, vanadium, zirconium, copper, lanthanum. 8 names that, measured against the standards regulators use for what's safe to have sitting in residential ground, mostly sit close to the line or under it. Present, documented, real. But not on their own the thing that should keep you up at night. The 9th one is arsenic. And arsenic is the one that clears the government's own residential safety screening level. Not by a hair, but by a margin substantial enough that Perry's own research flags it as the standout of the 9. Out of everything that 100+ years of accumulated runoff left behind in that basin, arsenic is the one element where the exposed crust is genuinely delivering more than what's considered safe to live around. I want to be exact about what that does and doesn't mean, because this is exactly the kind of moment where a channel like this one earns your trust or loses it. It does not mean the air over Salt Lake City is currently poisoning people on a measurable day-to-day basis. Here's the honest, harder-to-headline part of this story. When researchers with Utah's own Department of Environmental Quality have gone and actually measured airborne arsenic levels in the years since the lake started dropping, The highest concentrations they've recorded have come in at roughly 100 times below the health threshold that a state like California uses for airborne arsenic risk, 100 times below. And just as important, they have not yet found a clear, consistent historical increase in airborne arsenic or other metals correlating with the lake's falling water levels. At least not so far, not in the record as it stands today. The scientists closest to this problem are remarkably candid about that gap. Their own honest position, in plain language, is that it is still too early to know the true human impact. Nobody has yet nailed down, with real precision, how much of that dust the average person downwind actually inhales during one of those 15 or so storm events a year, or what that adds up to over a lifetime of living in that corridor. The hazard sitting in the ground is proven, documented, measured, mapped down to the hotspot. The dose reaching human lungs at scale over time, that part is still an open question, honestly labeled as open by the very people whose job it is to answer it. So hold both of those facts at once, because that's what honest science sounds like. The lid is coming off a genuinely toxic legacy. That part isn't in dispute, and the size of the actual danger to a person breathing on the Wasatch Front tonight is not yet fully known. That part isn't settled either, and anyone who tells you with total confidence exactly how many years you have left to breathe safely in that valley is saying more than the data currently supports. There's a reason I'm not soft-pedaling that uncertainty, because this is not the first time in American history that a shrinking lake has turned its exposed bed into an airborne hazard. It's happened before, fully, completely, on a scale that gives us something Utah doesn't yet have, an ending. In 1913, hundreds of miles to the west, in California's Owens Valley, the city of Los Angeles finished an aqueduct designed to carry water from the Owens River clear across the desert to a growing city on the coast. The river had fed Owens Lake for longer than anyone could remember. Once the aqueduct opened and the diversion began, the lake had nothing left to replace what evaporated. Owens Lake began to die. And by the mid-1990s, more than 80 years after that first diversion, the roughly 110 square mile bed left behind by that vanished lake had become the single largest source of a specific kind of fine airborne particulate, the kind small enough to lodge deep in human lungs in the entire United States. Not the largest in California, the largest in the country, one dried lakebed, outpolluting every other source of that particulate class in America. It took Los Angeles's own water utility spending well over $2 billion. Estimates across different reporting years run from around 2.1 up to 2.5 billion, and physically reflooding roughly 49 square miles of that dead lakebed, mostly through shallow, deliberate flooding, just to bring the dust under control. And that effort isn't a finished chapter from decades ago. It is still ongoing today, more than a century after the aqueduct first opened. 113 years, and counting, of an American city paying to manage the dust its own diversion created. That's the closest American precedent. But it isn't the most extreme one on record. For that, you have to go further, to a sea on the other side of the world that didn't just shrink, it nearly vanished. Starting in the 1960s, Soviet irrigation planners diverted the rivers feeding the Aral Sea in Central Asia to water cotton fields across the surrounding desert. Over the following 3 decades, through the 1990s, the sea did what any terminal body of water does when its inflow is cut. It began evaporating away, faster than anything could replace it. What emerged from underneath it wasn't just bare ground. It was a basin laced with the residue of decades of agricultural chemistry, organochlorin pesticides, names like DDT, lindane, aldrin, compounds banned in most of the world today, mixed with the salts the retreating sea left behind. Wind picks that mixture up off the exposed basin, now known as the Aralcombe, and carries it as toxic dust salt storms that have been documented traveling as far as 300 miles from their source. 300 miles. Far enough to cross international borders, to settle over cities and farmland that never touched the sea itself, carrying a chemical legacy manufactured decades earlier and an ocean of salt on top of it. The health toll in the region has been widely reported: elevated rates of respiratory disease, anemia, and, in some accounts, elevated cancer risk among the populations living closest to the basin. I want to be careful here, the same way I was careful with the arsenic numbers a moment ago, because not all of that is settled with the same certainty. Some of the specific health outcome research behind those claims is less firm than the geography and history around it, some of it drawn from animal studies rather than direct human data, some of it harder to isolate from the dozens of other hardships that came with the Soviet Union's collapse in that same region and same era. The desiccation of the sea itself, and the fact that its exposed bed produces toxic dust that travels for hundreds of miles, is not in question. Exactly how much of the regional illness traces directly back to that dust, as opposed to everything else going on in Central Asia across those same decades, is a harder thread to pull cleanly, and honest researchers say so. But even holding that caveat, look at what you now have in front of you. 3 basins, 3 different centuries of engineering, 3 different governments, 3 different rivers, a federal aqueduct built for a growing coastal city in 1913, a Soviet irrigation scheme built to grow cotton in a desert starting in the 1960s, and a natural terminal lake in Utah fed by mountain snowmelt and drained today not by one dramatic diversion, but by the accumulated draw of agriculture, industry, and a growing population pulling water out of its tributaries a little at a time. Different causes entirely. And yet the same 4-step pattern plays out in every single one of them, like a mechanism that doesn't care what century it's operating in, or what language the government spoke that triggered it. Reduce the inflow to a lake that has no outlet but evaporation. The water leaves faster than it's replaced. The bed that surfaces underneath releases whatever was hidden in its sediment, and whoever lives downwind inherits an airborne legacy they had no hand in creating, and in most cases, no warning about. Utah is not the first place this has happened, and there's a 4th basin already following the same 4-step pattern in real time in the same country, roughly 600 miles away. California's Salton Sea, its retreating shoreline exposing sediment laced with its own arsenic and selenium, its own downwind communities already documenting respiratory effects. Nobody frames the Great Salt Lake as an isolated event anymore, not among the people who study these basins for a living. They talk about it as the next one in a sequence they've already watched play out at least twice before, on 2 different continents. Which brings us back to that document I asked you to hold on to at the start, the one from January of 2023, signed by 32 scientists, led out of Brigham Young University by Benjamin Abbott. Its title alone tells you the tone the authors chose. Emergency measures needed to rescue Great Salt Lake from ongoing collapse. Not a routine annual report, an emergency briefing, deliberately named as one, put out by researchers who felt the normal pace of scientific publication was too slow for what they were watching happen. Their warning, in plain terms, without serious immediate intervention, the lake was on a trajectory that could bring it to something close to total desiccation within about 5 years. 5 years. Not 50. Not a distant mid-century projection safely beyond any of our lifetimes. A number close enough that people reading it in 2023 could reasonably expect to watch it happen, or not happen, within the same decade. Half a year before that emergency briefing was even published, a Utah state lawmaker named Joel Ferry gave an interview to a reporter at the New York Times and reached for the starkest language he could find. He called the lake's collapse an environmental nuclear bomb. I want to be precise about what that phrase is and isn't. It is a politician's quote given in a moment of real alarm to a national newspaper about a crisis he clearly believed was being underestimated. It is not a scientific forecast, not a modeled prediction, not a number anyone measured. It's rhetoric, vivid, deliberately frightening rhetoric chosen by a man in public office trying to make people outside Utah pay attention to a slow-motion emergency most of the country had never heard of. Treat it as what it is, the sound of alarm, not the shape of the science. So what actually happened in the years since that emergency briefing landed and that quote made headlines? This is where the story refuses to move in a straight line, and where being honest with you matters more than being dramatic. The lake did not desiccate on the timeline the alarm implied. Utah had a genuinely strong snowpack winter not long after that briefing was published, and the runoff from it pushed the south arm up by something like 3.5 feet net over the following season. 3.5 feet doesn't sound like much against a lake that's lost dozens of feet of depth over generations, but it was real, measured recovery, proof the system can still respond to a good winter, that this isn't a one-way ratchet with no way back. And yet, by the 2025 water year, after that recovery, the South Arm still closed out somewhere between 4,191.1 and 4,191.3 feet, the third lowest level ever recorded on that same long instrument record. Not the record low anymore. Third lowest. Better than 2022. Nowhere close to what water managers consider healthy. And healthy, in this case, isn't a vague word. It has a number attached to it. Scientists studying this lake put a healthy target elevation at around 4,198 feet. To close that gap by 2055, Utah's own Division of Water Resources estimates the lake needs something like 800,000 additional acre-feet of water flowing into it every single year, beyond what it's getting now, sustained for 3 decades straight. That is the actual shape of recovery here. Not a wet winter and a sigh of relief, but 3 decades of deliberate, sustained, above-normal inflow, delivered on purpose year after year, to close a gap that one good snowpack barely dented. And that number, 3 decades sustained on purpose, is the moment this stops being a story about one lake in one state and turns into something else. Because think about what a target like that actually requires. It requires farmers upstream using less water than they're used to. It requires cities along the Wasatch Front rethinking lawns and golf courses and the reflexive habit of watering a desert like it's somewhere green. It requires industries that have always treated the rivers feeding this basin as a free input to start treating them as a shared, finite account instead. Nobody gets to keep taking the way they always have and also get the lake back. That's the trade the number's actually describing. And once you see that trade clearly, you start noticing it isn't unique to lakes at all. It's the same shape as almost every slow environmental account coming due that we've stopped paying attention to, because nothing dramatic seems to be happening. A groundwater aquifer, drawn down decade after decade for irrigation, invisible until wells start running dry. A fishery pulled from a little harder every year than it can replace, invisible until the boats come back empty. A climate system absorbing a little more heat every year than it sheds, invisible until a summer arrives that breaks every record at once. In every one of these, something is being withdrawn steadily, quietly, from an account that has no outlet for what's put into it and no natural mechanism to replenish itself at the rate we're taking from it. And in every one of these, the shortfall stays invisible for years, sometimes generations, because the system doesn't scream when it's being depleted. It just quietly runs down, the way a lake quietly drops 3 inches a year for 100 years, until one day, the number that used to be an abstraction on a hydrologist's chart becomes the actual air in your actual lungs. That's the pattern the Great Salt Lake is showing us at a scale small enough to actually see, start to finish, within a single human lifetime. Most of these accounts are too large, too slow, or too diffuse to watch collapse in real time. This one, you can. Kevin Perry could ride a bicycle across the entire liability in 2 years. You cannot ride a bicycle across a depleting aquifer or a warming ocean or a fishery running out a little more each season. But you can ride one across this lakebed and measure exactly what a century of unpaid environmental debt looks like when it finally surfaces, one soil sample at a time. It's a strange kind of privilege, if you can call it that, getting to watch at a legible human scale, in your own country, in your own decade, what it actually looks like when an invisible account finally comes due. Most of the planet's slow reckonings are too big or too gradual to ever resolve into something you could point a camera at. This one resolved. It surfaced as pale crust on cracked ground, mapped hotspot by hotspot, element by element, until the abstraction had a location and a chemistry and a wind direction. So let's turn this toward you directly, because that's really what this has been building to. If you have never set foot in Utah, if you have never seen the Great Salt Lake, none of what I've told you so far is really about a place. It's about a question that applies to your body no matter where you're standing right now. What have you been breathing this whole time without ever being told to ask? You don't get to choose your air the way you choose your food or your water. You can read a label on a bottle. You can look up what's in your tap water with a few keystrokes. But the air moving in and out of your chest right now was somewhere else yesterday, and the day before that, and you have no practical way of tracing its route back to every basin, every industrial site, every drying lakebed it might have crossed on its way to you. It arrives already mixed, already history, and you inhale that history a few hundred times an hour without ever seeing an ingredient list. Somewhere in Salt Lake City tonight, someone is going to sleep with their window cracked, breathing air that, on a windier day earlier that week, may have carried a trace of arsenic that has been sitting at the bottom of a lake since before their grandparents were born. Not as a certainty. Remember, the actual measured airborne concentrations researchers have found so far sit roughly 100 times under the threshold California uses for real concern, and nobody serious is telling residents to panic tonight. But as a genuine, honestly labeled possibility, on the specific days when the wind comes off the wrong hotspot at the wrong speed. 100 years of accumulated mining runoff and industrial residue, dissolved into rivers, carried into a basin with no way out, settled into mud, sealed under a crust, and only now, in your lifetime, in your decade, beginning to circulate back into a human respiratory system. That lake was never separate from the people living around it, no matter how far downwind they thought they were standing. It was always downstream of everyone's choices, and everyone downwind of it was always, quietly, downstream of its condition in return. The mountains send their runoff into the lake. The lake, when it's full, keeps that runoff to itself. And when it isn't full, the wind sends a fraction of it back out to the people who thought the exchange only ever went one direction. There's something almost unbearably intimate about that loop, once you actually see it. Not a distant headline about an environmental statistic in a state you may never visit. An actual physical exchange between a body of water and a few million sets of lungs playing out on a schedule set by snowpack and drought and how much water gets pulled out of rivers before they ever reach the lake at all. The lake doesn't know it's being watched. It doesn't know its bed is being sampled, mapped, screened for 53 elements. It is simply doing what any uncovered basin does when the water that used to seal it disappears, releasing, slowly, indifferently, whatever it was asked to hold on to for a century, back into the same air that everyone downwind assumed was simply theirs. Take a breath right now, wherever you're sitting. Feel your ribs expand. Feel the air move down into that space behind your sternum, into the branching passages that get smaller and smaller until they're too fine to see, deep enough that whatever rides in on that breath has nowhere left to go but into you. Ordinary air does this to you a few 100,000 times a day, and you never think about it, because thinking about every breath would be unbearable. That's not a flaw in you. That's the only way a body can function, by trusting the medium it depends on most, the one thing it truly cannot live seconds without constantly interrogating it. And most days, in most places, that trust is earned. Most days, the air over the Wasatch Front is just air, dry, high desert, unremarkable, nothing riding in it but pollen and ordinary dust. This isn't a story about every breath being dangerous. It's a story about how the definition of ordinary quietly shifted under an entire region's feet over exactly the span of time it took a lake to fall from full to a third lowest ever reading without a single person choosing that shift or voting for it or even necessarily noticing it happen. Think about how strange that timeline actually is. Kevin Perry could have been born, gone to school, built an entire career studying the atmosphere. And only in the back half of that career did the ground he was measuring even exist in its current exposed form. The lakebed he rode a bicycle across for 2 straight years is younger as bare ground than he is as a person. That's not deep geological time we're talking about, not something measured in the slow language of rock layers and ice cores. That's a single human career, watching a landscape change category, from lakebed to hazard, inside one lifetime, inside one set of eyes. And that's really the unease sitting underneath all of this if you let it settle. We tend to think of environmental damage as something that happened, a spill that occurred, a factory that once dumped something, a bad decision made by people who are mostly gone now, leaving the rest of us to simply live with the aftermath. But this lake tells a different story. The damage here isn't a single past event you can date and close the book on. It's an ongoing withdrawal, still happening, still compounding, every single dry year, adding a little more exposed crust to a total that was already large enough to reshape the air 2.5 million people share. The account isn't closed. It's still open and still being drawn down in the same years you and I are alive to watch it. And that ongoing withdrawal is exactly why this isn't a story that stopped being written in 2023. Separately from that emergency briefing, a different, longer-running effort, a group working out of the University of Utah's Kem Gardner Policy Institute, alongside the Wilkes Center, has been publishing its own annual reports on this lake every year since that same year, tracking reservoir levels, tracking salinity, updating the hydrology in public on a yearly cadence, whether or not the news cycle is paying attention that particular season. It's a quieter document than the emergency briefing, less built for alarm, more built for bookkeeping. But bookkeeping is exactly what an account like this needs, and exactly what most of the planet's slow-moving environmental debts never get. Most drawn-down aquifers don't have a team publishing an annual public statement on exactly how far underwater they are. This lake does. Someone is keeping the ledger, in public, on purpose, every single year, specifically so that nobody gets to say later that they didn't know, that the numbers weren't published, that the account's balance was ever a secret. That's a strange kind of mercy when you think about it, that this particular slow collapse comes with a running total. Most of us live downstream of accounts we'll never see itemized. This one, anyone can go and read. The salinity figures, the reservoir levels, the season-by-season inches gained or lost, all of it sitting in public documents updated on schedule by people who have made watching this lake's vital signs into their actual job year after year, long after the initial emergency headlines faded. And still, the ledger keeps recording the same basic fact underneath all the yearly detail. A good winter buys back a few feet. A dry one takes back more than that. The long-term trend line, across all the years these reports now cover, still points the same direction it did when Kevin Perry first got on his bicycle. Down, slower some years than others, but down. The crust keeps drying. The 9% keeps being a floor, not a ceiling. And somewhere in that widening gap between the lake's current elevation and the 4,198 feet scientists call healthy, the next stretch of stable 76% crust is quietly waiting its turn to crack. What does that waiting actually look like on the ground for the people living in that gap? It looks smaller and more mundane than the phrase environmental crisis usually suggests. It looks like an air quality notification landing on a phone on a dry, windy afternoon in late summer, the kind of alert that used to mean wildfire, smoke drifting in from somewhere else, and increasingly can mean something closer to home. It looks like a parent deciding whether the soccer practice happening outside that evening should move indoors, based on a number on a screen they didn't used to have to check. It looks like windows that used to stay open on a warm night now getting shut a little earlier, a little more often, for reasons that have nothing to do with cold and everything to do with what might be riding on the breeze. None of that is dramatic. None of it looks like the crisis a phrase like environmental nuclear bomb conjures in your head. It looks like small, quiet, adaptive behavior, the kind entire populations develop without ever holding a meeting about it, the way a coastal town learns to watch the tide tables or a river town learns to watch the snowpack reports upstream. Utah's Wasatch Front is, right now, in the early stages of learning to watch its lake the way other places learn to watch a fault line or a floodplain, not out of panic, but out of the same quiet vigilance you'd bring to any neighbor whose condition you can't fully control and can't afford to ignore either. And that vigilance cuts both ways, because the lake isn't only a threat to be monitored, it's a body its neighbors still depend on in ways that have nothing to do with dust. Millions of migratory birds still stop there every year, on a flyway that has used this lake as a waypoint for longer than any human settlement nearby has existed. An entire brine shrimp industry still draws a living from its water, while it still has water to draw from. Ski resorts in the mountains above it still benefit from the lake effect moisture the water surface itself helps generate, feeding back into the very snowpack that determines how much runoff reaches the lake the following spring. The lake isn't a hazard sitting apart from the region's life. It's woven into the same system it's now threatening, a single, damaged organ trying to keep functioning for the same body that depends on it. That last piece is worth sitting with for a second, because it isn't just a poetic detail. It describes an actual feedback loop, one that makes the whole situation harder to simply outwait. A large open body of water like this doesn't just sit passively in the landscape. It contributes moisture to the air above it, moisture that mountain storm systems downwind can pick up and turn into extra snow on the peaks above. Less lake surface means less of that moisture rising off the water. Less moisture rising off the water can mean less snow accumulating on the very mountains whose spring melt is supposed to refill the lake the following year. A smaller lake can, in a real physical sense, make it slightly harder for itself to recover, not through some mystical curse, but through simple atmospheric mechanics, less surface area contributing less to the systems that would otherwise replenish it. That's the quiet cruelty hiding inside a mechanism that otherwise sounds almost administrative. Inflow, evaporation, deficit, recovery target. It isn't a static math problem where the number holds still while everyone decides how to fix it. It's a living system, capable of tightening its own bind a little further each year it stays low, the way a wound that isn't tended can make itself a little harder to heal the longer it's left open. Every year the lake spends below that 4,198-foot healthy line isn't a neutral pause before an eventual recovery. It's a year in which the conditions for recovery may be getting slightly less favorable, not more. Kevin Perry, for his part, didn't stop paying attention once his bicycle survey ended. Researchers like him keep returning to this basin, season after season, because a map of contamination taken once is a snapshot, and a snapshot of a system that's still actively changing goes stale the moment new crust cracks and new ground gets exposed to wind for the first time. The 9% active dust figure from his team's work isn't a number etched in stone. It's a number that describes one moment in an unfinished process, watched by people who know full well they'll need to measure it again and again for as long as the lake keeps dropping. And that raises the question this story keeps circling without ever quite landing on a single villain, because there isn't one. Nobody stood at a control panel and decided to drain the Great Salt Lake the way a single aqueduct decision drained Owens Lake, or a single Soviet ministry decided to redirect two rivers away from the Aral Sea. This one happened by accumulation, thousands of individual reasonable-seeming decisions made over decades, by farmers irrigating fields that fed families, by cities growing to house more people who all needed water, by industries drawing from rivers that seemed, at the time, too large to notice a single straw. Nobody was trying to kill a lake. They were trying to grow alfalfa and grow a city and grow an economy using the water sitting right there in the rivers that happened to end at this particular basin. That's a harder story to tell than a villain would be, and a harder one to fix. You can shut down one aqueduct valve, the way engineers eventually reflooded sections of Owens Lake once the damage was undeniable. You can end one irrigation program, however imperfectly, once a government decides the cost outweighs the cotton. But you cannot shut off 100,000 small, individually reasonable water uses with a single valve. Undoing this kind of damage means renegotiating all at once a web of decisions made by farmers and cities and industries who each did nothing wrong on their own, and who each nonetheless contributed one small, incremental withdrawal from an account that had no outlet and no natural way to refill itself faster than it was being drawn down. That is, in the end, the real difficulty sitting underneath every optimistic number in this story. The 800,000 acre-feet a year, the 3 decades of sustained effort, the 4,198-foot target. None of those numbers require one dramatic act of political will, the kind you could point a camera at and call heroic. They require thousands of smaller acts of restraint, sustained for a generation by people who mostly can't see the lake from where they live, who may never breathe a single lungful of its exposed dust, and who are nonetheless being asked to use a little less water year after year for the sake of 2.5 million neighbors downwind whose faces they will likely never see. If you ever actually go stand at the edge of this lake today, you don't need a scientist's instrument to feel the shape of what's been lost. You can see it with your own eyes. Boat ramps built decades ago now end in cracked, dry ground, sometimes hundreds of yards short of any actual water. Marinas built for a shoreline that has since retreated, stranded, docks reaching out over dust instead of waves. There are places around this basin where you can stand on what used to be lakebed, look toward a shrunken sliver of blue water in the distance, and understand, physically, in your legs and your eyes, what 100 years of quiet withdrawal actually looks like laid out in front of you. Most environmental damage stays abstract, a graph, a statistic, a report you never read. This is one of the rare ones that you can walk out onto. If this is the kind of rabbit hole that gets its hooks into you the way it got into me, this channel goes looking for exactly this kind of story. Real, verified, and stranger than it first appears, so it's worth sticking around for the next one. Because here's what I keep circling back to, turning it over. This isn't a story about a faraway lake in a state you may never visit. It's a demonstration, running in real time, of what happens to any account that only ever takes deposits and never allows a withdrawal. Whether that account holds water, or heavy metal, or carbon, or anything else a modern civilization quietly generates and assumes some larger system will simply absorb forever. The Great Salt Lake didn't fail because it was uniquely mismanaged. It failed because it followed the plainest rule of any closed system. What goes in and never comes back out eventually fills every available space. And when the thing holding it down finally recedes, everyone standing nearby finds out, all at once, exactly how full that account had actually become. Nobody currently studying this lake will tell you how the story ends, and that's not a gap in the science. It's the most honest thing anyone connected to this crisis can say. The account could still be rebalanced. The 3.5-foot rebound after that one strong snowpack proves the system hasn't crossed some point of no return, that inflow still moves the needle, that this isn't yet a lake locked into an irreversible slide the way Owens Lake was by the time anyone intervened. But it could also keep sliding, a few inches at a time, through an ordinary run of dry winters, past the point where any sustainable amount of restraint upstream could catch up to what's already been lost. Both futures are still open. Nobody alive today, not Kevin Perry, not the 32 scientists who signed that emergency briefing, not the researchers filing the annual hydrology reports, actually knows which one is coming. They only know which one requires action starting now and which one arrives if nothing changes. That uncertainty is not a comfortable place to leave a story, and I'm not going to pretend it is, but it's the true place, and there's a kind of respect in leaving it exactly where the evidence actually sits, rather than rounding it off into either false alarm or false reassurance. The lake is not doomed. The lake is not safe. It is, right now, tonight, exactly as undecided as the account itself, 100 years of deposits, still sitting there, waiting to see whether anyone upstream chooses, finally, to make a withdrawal in the other direction. Picture what that bicycle survey actually felt like in the body, because it's easy to hear 2 years, 2,300 miles, and let it stay an abstraction. This is high desert. Summer temperatures out on that exposed playa can climb well past anything comfortable for sustained physical work, with no shade anywhere across miles of flat, pale ground, and no water source except what he carried. Winter brings the opposite problem: cracked mud frozen into something like broken pavement, wind with nothing to block it for miles, cutting straight off the remaining open water. He rode through both. Not once as a stunt, but as a discipline, returning to the same grid, season after season, because a single dry summer's samples wouldn't tell him what a full annual cycle would. And what his hands were actually closing around, bag after bag, wasn't simple dirt in the way most people picture dirt. Dark, loamy, ordinary. Lakebed sediment that's been sitting under mineral-rich water for a century behaves differently once it dries. It often comes up pale, sometimes almost white, crusted with salts that crystallize as the last moisture wicks away, brittle enough to crack under a boot the way ice cracks on a puddle. Underneath that pale crust, the subsurface layer he was also sampling, the third sample at every site, tends to be darker, finer, less oxidized, closer in texture to something like flour than to soil. That's the material his 53-element screen was actually testing, not chunks of visible rock. A fine, wind-liftable powder sitting a few inches under a thin, breakable seal. The reason the texture matters so much comes down to a single physical fact about human anatomy that's worth sitting with directly. The particulate category researchers call PM10 refers to particles 10 micrometers across or smaller. For scale, a single human hair is roughly 70 micrometers thick, meaning you could fit 7 or more of these particles across the width of one strand of hair. Particles that small don't get stopped by the nose, don't get trapped in the throat the way ordinary coarse dust does. They ride the airstream straight down into the lungs, deep enough to reach the smallest branching passages, the ones with no more filtering left to offer. That's the actual mechanism turning a windstorm over cracked lakebed into something worth measuring in a human body instead of just an air quality gauge on a rooftop, not visible grit landing on a windshield, an invisible fraction fine enough to disappear on the way in. So take one more breath, right now, the way I asked you to earlier. Feel it move down into your chest, into the space that trusts the air without ever asking it to prove itself. Somewhere out past that breath, a man is still riding a bicycle across cracked ground that used to be a lake, still kneeling down every 500 meters, still bagging what a century left behind because someone has to keep checking. The lake hasn't decided how this ends. Neither has the wind. All either of them has ever done is wait to see what happens next. And now, so are you.